Hello everyone. Recently, I working on an electromagnet simulation. And there is a problems that the iron core didn't saturate. I'm really not sure what's going on. This model was created in Creo. As you can see, the structure is pretty simple. There's hosting shell and the pole shoes. And there is an isolation ring made of tin bronze. It's designed to block the magnetic through here. Then there's the armature and the push rod. These things have two coils connected in parallel. Later in Maxwell, I'll combine them into one coil. It can simplify calculations. The armature and push rod are connected. They are moving together like this. Save it to the desktop. STP. I've already done this before. Open Maxwell. Go to Maxwell 3D. Modeler. Imports. Select the file we just saved. The push rod doesn't need to be included in the calculation, so let's delete it to reduce the mesh. Merge the two coils. Unite. Assign materials. Copper shore. The isolation ring. Let's just use stainless steel. I don't have QSN43 in the library, and I'm too lazy to create a new material. They're pretty similar anyway. Then for the rest. DT4E. This is a custom material I defined. As you can see, it has a BH curve. I got this curve from seller. Confirm. Next, set up the solution region. Region 50%. Okay? Set the material as air. Then create the current plane. Section. Choose YZ or XZ. Split them using Boolean. Separate bodies. Delete this one. Assign a current. The equivalent number of turns is 540. Coil type. Standard. Current variable is created automatically. Initial value, let's set it to 0 or 1. Select the armature. This is what will analyze the force. Parameters. Force. Keep it virtual. And next, create a new analysis. 10 isn't enough, let's set it to 18. That should be fine. A larger error tolerance means faster convergence. Everything else can stay as default. Finally, set up the variable I. Add parametric. I from 0 ampere to 1 ampere. Step 0.1. Then from 1 to 10. Step 1. Next, add a single point at 100 ampere. Okay, then go to options. Save fields and mesh. We'll need this later during analysis. Check no errors, all green. Very good. Analyze all. Oh, let's save it to somewhere. Disk C. Document. Ansoft. Okay, now it's running. Let's wait patiently for the calculation to finish. I'll fast forward here. Alright, the calculation is done now. Let's check the log. No errors. No warnings. Very good. Check results. Look at the convergence process. Total energy is very stable, no sudden jumps. Check other points. They look good too. Another one, still good. The log shows no errors. Now check the results. Force. Force C. Look, the results at 100 ampere, it's showing 1400 newtons. This way too high. Let's take a look in MATLAB. I've already exported the data. Here, I also analyzed the force using steel 1008 for the armature. This is a material provided by Ansys with an official BH curve. Run it. The blue line represents the measured values, and the red one is DT4E. You can see that initially it matches the measured values pretty well. But as the current increases, it doesn't show magnetic saturation. The steel 1008 curve behaves similarly, though the values are different. The trend is the same. For this plot, I only draw points within 1/0. Now let's plot all the points. Boom. As you can see, the DT4E didn't show saturation, and the Ansys official 108 steel also didn't show that point. The force is surprisingly high. This is completely abnormal. I have no idea why. Let's go back to Maxwell and check the B field distribution. Animate. Remove this abnormal 100 ampere point. I can't tell. This magnetic flux density distribution hasn't shown saturation. Because 3D simulation spends too much time, I already turned it to a 2D model. Everything is properly set. Check. All green, no error. Here I run the simulation again, hope it can save my life. Okay, simulation is done with no error. Let's calculate the maximum magnetic flux density and maximum magnetic field intensity. Calculator. Quantity, H. Magnitude. Geometry. All objects. Maximum value. Okay. Max, H. Let's do it again to calculate the B field. Quantity, B. All objects. Maximum value. Okay. Max, B. Result. Create fields report. Rectangular plot. Max, H. Do it again. Max, B. Alright, let's plot force curve again, do some control comparison. There, I replot this curve in MATLAB. Here is IF curve. Basically, it's matched very well under 6 ampere, but above 6 ampere the simulation does not show saturation. The force still increases linearly with current. Here are IH, IB, and IF curves in all volumes just I added in calculator before. You can see the magnetic flux density and magnetic field intensity show perfect saturation, but the force does not. That is so weird. According to my poor knowledge of physics, the force F should be proportional to the square of B. But this simulation did show that point. I plotted an IF, B square curve. It should be a constant value, but the ratio in the simulation keeps increasing. That really confused me. This picture shows IH, IB, and IF curves at a specific point in the minimal section area. Basically, it just follows the all volumes curve. Is there some key process I missed? I can't figure this simulation out. About to burn out my brain cells. Please, God, save me.